This is section 7.6, variation. These are all technically word problems, but what we're going to be talking about are things that have a constant relationship between each other. So, for example, we all know that the more you smoke, the higher your chances of lung cancer. So, the more you smoke, the higher your level of lung cancer. Now, maybe they don't go up at the same rate exactly. They go up in some sort of constant rate in relationship to each other. Okay, this would be an example of what we call direct variation. In direct variation, if one goes up, the other goes up. If one goes down, the other goes down. Okay, not necessarily by the same amount, but by a constant amount, some sort of relationship with each other. Then we are also going to have what we call inverse variation. And this would be something like where things go in opposite direction of each other. So for example, let's talk about sunscreen. The more you wear sunscreen, the less your chance of getting skin cancer. And it goes the other way around too. If the less you wear sunscreen, the higher your chances of getting skin cancer. Okay, so these are the kinds of things we're going to be talking about here. On every single one of these problems, we're going to have a K in the formula we use. This is the constant that takes care of how closely these are related to each other. We call it the constant of variation, and it will appear in every single variation problem. Okay. Now we talked about direct variation. This is where things are moving in the same relationship. You're going to see something like y varies directly as x, or you might see the word proportional here. Y is directly proportional to x, something like that. If there exists some constant k, which is this k way up here, such that y is equal to k times x. What you need to do is you need to learn to connect this word directly to this basic formula. Where you're going to translate the word varies, we're going to translate varies to equals k. Okay? Every time we see the word varies, we'll write equals k, and then if it's word directly, we're going to write the next letter directly beside it. Okay? Inverse variation is where things go in opposite order of each other. You'll see y varies inversely as x, or maybe y is inversely proportional to x. If there exists some constant k, like we said, there's k in every one, such that y is equal to, so we're going to write, if you see, you're going to write your first word on both of these, okay? So your first variable, y equals k, because it says y varies, y equals k. The word directly tells me that the next variable is going directly beside the k. Inversely means the x is going to go in the bottom. Okay, so you need to connect this word inversely with this formula. Inversely, the next variable goes underneath the k. Okay, these are our two main types of variation. We also have what we call joint variation. This is direct variation, but with more than one variable. So it says y varies jointly as x and z. So we have two variables here, but they go directly beside the k. So this is direct variation with a couple of extra variables. Okay? So let's look at some problems. Like I said, they're all going to work exactly the same way. If x varies directly as y, and x equals 10 when y equals 7, find y when x equals 50. Now these sound awful if you read them all the way through. The thing is, your commas in these problems break it up into steps. This is our first step. We're going to find a way of writing an equation that models this. So these are going to be the formulas from the previous page. The next thing we're going to do between these two commas is we're going to be given enough information to find k. And then for here, we're going to write the improved formula. And what I mean by that is we're going to know what k is, so we can plug k into our original here, and we'll have an improved formula. Then use it. And this is how it works on every single variation problem. Okay, so let's look at this first one. X varies directly as Y. Here, if you're comparing here, and here we have Y and then X. On this problem, we have X and then Y. So it's really the only difference. What you do is you said, if X varies, that tells me I'm going to ignore the rest of this. X equals K. Directly tells me that whatever comes next is going to be written directly beside the K. So a Y right here. This is my original equation. That's what I get from this first phrase. Okay, now let's use the second bit. X equals 10 when Y equals 7. So we're going to plug in X equal to 10 and then Y equal to 7, and that will be enough information for us to find our constant. So X is 10 when Y is 7, so that's 7K. We can divide both sides by a 7. And I know that my K value is 10 over 7. Okay, so I've used this now. I've done this step, I've done this step, now I just have this one. We're going to write our improved formula. So we're going to take this and plug it in here. My improved formula is X is equal to 7 over 10 Y. I know what my K value is, I've plugged it in. All right, so now we use this. Find Y when X equals 50. So I'm going to plug in 50 right here. Okay. Now I can kill my fraction by multiplying both sides by a 7. Here, that's just going to cancel that out, and I'll have 10y on that side. 7 times 50 would be 350, is equal to 10y. Divide both sides by a 10, and you get 35 is equal to y. This is the answer they're looking for. Okay? On all of these problems, you will be given enough information to write a general formula. Then you will be given enough information to find your constant. Then you rewrite your problem, and then you'll be asked to use it. And the final thing is what you're looking for here. Okay, so let's work another one. If x varies inversely as x, and t equals 3 when x equals 5, find x when t equals 5. Okay? If t varies, so that tells me t equals k. Inversely tells me that this next variable, which is x, is going to go underneath the k. If you compare it to here we had y and then x, and then we had y here and the x went in the bottom. Here we have t and x, and the t is in the same position as the y. The x is, of course, in the same position as the x. So that's our starting equation, starting formula. Now use this information. T equals 3 when x equals 5. So this is 3 when x equals 5. That's enough information to find k. Just multiply both sides by a 5. And we find that 15 is equal to k. Now we rewrite our formula. So t is equal to 15 over x. Now find x when t equals 5. Now you can probably do this in your head. You're simply asking yourself 15 divided by what gives you 5. But you know, it's not always going to be that easy. So here I'll multiply by x over 1 times x. So this is 5x is equal to 15. If you divide both sides by 5, you'll see that x is equal to 3. And this is what you're looking for, x equal to 3. Okay, so let's try this one. If f varies jointly, so this is the direct variation with more pieces. If f varies jointly as g squared and h, let's write that, okay? F varies, so f equals k. Jointly tells me that whatever comes next is going to be written directly beside it. So g squared and h. Don't let that square mess you up. It's basically the same spot as a variable, and we treat it exactly the same way. Okay, so we've used our first phrase. Now these sound worse because you have more information, you have more variables to fill in for, but they still work the same way. F is 50 when G is 4, so I'm going to write K times 4 squared times H, which is 2. So this is 50 is equal to K times 16 times 2. So 50 is equal to, that's going to be 32 over K, 32K. Divide both sides by 32. And then you get 50 over 32, which reduces to 25 over 16. And that is equal to my K value. Okay. Now I'm going to rewrite my equation using this K value. F is equal to 25 over 16 G squared H. Okay, so we've used this information. Now find F when G is 3 and H is 6. So F is equal to 25 over 16 times 3 squared times 6. So this is 25 over 16 times 9 times 6. So this is 25 over 16 times 54 over 1. All right, both of these are divisible by 2. So if I divide this by 2, I get an 8. If I divide 54 by 2, I get 27. Now I'll multiply straight across. 25 times 27 is 675 over 8. So your F value, which is what we're looking for, is 675 over 8. And if they ask you to write this in as a mixed number, you would just do the division and you would get 84 over 34 and 3/8 as your answer. Okay, so let's work one more. This one's different only because it's in the real world and we're going to have to supply our own variables. But they're going to work basically the same way. Okay? The weight of an object on Earth is directly proportional to, so this is a direct variation, to the weight of that same object on the moon. Okay? So I have two values here. I have the Earth weight and I have the moon weight. So let's call X the Earth weight and the moon weight we'll call Y. So now let's translate this first sentence. The weight of an object on Earth, which is X, varies directly or is directly proportional to, so equals K, and then whatever comes next is going to go directly beside the K, and the next thing that comes next is the weight of that same object on the moon. So that's my Y. So this is my starting equation. Now, instead of being broken up by commas, this one's broken up by sentences. But you can still see how it's phrased and everything works together. A 200-pound astronaut, that's going to be my Earth weight, would weigh 32 pounds on the moon. So that's my Y. So this is 32K. Now, if I divide both sides by a 32, I find that my K value is, if I reduce this, I can divide both of these by 8, and I'll get 25 over 4. So my improved equation is X is equal to 25 over 4 times Y. Now we get to use this. How much would a 50-pound dog weigh on the moon? So 50-pound dog, this is Earth weight, and Earth weight is X, so I'm going to put a 50 right here. And I need to solve for the moon weight, which is Y. Okay. To kill the fraction, I'm going to multiply both sides by a 4. These will cancel out. 4 times 50 would be 200, is equal to 25Y. Divide both sides by 25. And you would get 8 is equal to Y. So how much does the dog weigh on the moon? 8 pounds. And that would be your answer.